Right, so on Monday, you have your Wednesday, you have your last test of the quarter. It will be 15 questions long. It is multiple choice. There is no partial credit. So make sure you are reading the questions carefully. Make sure if it says to find the lateral area, that is all you're finding. If it's asking you total surface area, then you go ahead and incorporate the base also. Read it carefully. If it's asking for volume, do the volume formula. Don't use the surface area formula. The way that most test generators work is they're going to have the answer to both. So let's say it was a volume question and you didn't read it correctly. Chances are one of the choices will be a surface area answer. So make sure you're reading the questions carefully and that when you bubble your answer, you're bubbling the correct answer. So now for the material that's going to be important to you. I know it's a lot of information. However, from 11.5, we've already taken the quiz on 11.5, 6, and 7. You will have similar questions that you saw on the quiz. They will also be on the test. I've given those back to you. You can use those to study. From 11.5, this is where we were introduced to naming the solids. So be able to recognize what solid you're dealing with. If it's a prism, if it's a pyramid, if it's a cone, if it's a cylinder, be able to name it. Be able to name and count the number of edges, faces, and vertices. So be able to use Euler's theorem. So this first page of the study guide, you have a nice box of vocabulary and then identifying those figures in the example here and giving the number of edges, faces, and vertices. Then on the second page, they're introducing you to Euler's theorem. However, the bottom part, starting in example 3, you will not have any cross-section questions. So you can skip over that. Actually, you could focus on these. Sorry, let me undo that. So no cross-section, so no example 3. And so you can skip questions 5, 6, and 7. But these would be good because you're naming the number of edges, vertices, and faces there. So that's what you need to take away from 11.5 is be able to name the solid and then count edges, faces, and vertices. And then apply Euler's theorem. Then 11, and then the answers are on the last page. Then in section 11.6, this is where we learned how to find the volume of prisms and cylinders. Remember, the general formula is volume of these prisms and cylinders is represented by capital B times H, where the capital B represents the area of the base. So if your base is a triangle, you're going to do the formula for area of a triangle. Base times height divided by 2, or 1/2 BH. If your base happens to be a rectangle, you would do base times height or length times width. Remember, after you calculate that area of the base, to multiply that number by the height of the prism. So in here, we've got all the vocabulary and all the theorems that we learned. Again, here are some examples. You will not have any trapezoids. So example A here, you really won't have to do the area of a trapezoid. You will have cylinders. Remember, the capital B, when it's a cylinder, is pi r squared, because that's a circle, and then times it by how tall the cylinder is. So the second page, it actually has volume of a cube, so you can do that. You've also got some examples here that you can do. Remember, if the figure is oblique, all this is the height is outside of the figure. The formula is still the same. It's capital B times H. So even if the figure is oblique, like it's slanted, just look for the height outside of the figure. Now also, on this test, Be able to work backwards and forwards. Maybe not just necessarily calculate the volume. You might get a question where I either give you the volume or the surface area, and I ask you to find a radius or a height. So be able to take the formula and work backwards with it to find a missing dimension. So know your formulas and how to use them. Okay, so here, this is now the pyramids and the cones. And in 11.7, the formula, the general formula for pyramids and cones is the same thing as the prisms, but we're going to add in front of that 1/3 of that product. Okay, remember you could also find the area of the base times the height, and then at the end divide your answer by 3. So again, be able to calculate volume for pyramids and cones. Again, we talked about this when we did the quiz review. This is not a pyramid, this is actually a prism. So if you look at their solution, you can get rid of the 1/3 here. This is a mistake. So this isn't a good example of a pyramid. That would have been a prism, and then they did the wrong calculations. The cone calculation is fine. Again, they did 1/3 BH right here. And again, remember your base in a cone is a circle. So pi r squared times the height of the cone, and then divide by 3 or multiply by 1/3. So example 1 is perfect. You can practice finding the volume of that pyramid. The second page, again, they're asking you to find the volume of the pyramid. That's fine. This section here of using trigonometry to find the volume, you will not have any trigonometry on this. There will be no sine, cosine, or tangent. So you won't have to do that to find a radius or a height. So you can skip example 3. And there are the answers. Then in section 8, this is where we learn both the volume and the surface area formula for a sphere. So the surface area formula is right here, and the volume is right here. Again, it is on that reference sheet. So for this one, all we need is a radius. Remember, if they give you a diameter, to divide it by 2 first and make it a radius. And then you're going to plug it into the formula and then follow order of operations. So be able to calculate the volume and the surface area of a sphere. Also be able to work backwards. If I ask you to find the radius and I give you the volume already calculated, be able to work backwards through the formula. This page is also good practice for 11.8. Then in 11.9, this is where we saw properties of similar solids. So I'm going to give you, for example, down here at the bottom, I'm going to give you 2 solids, a small solid and then a larger solid. I'm going to ask you, are those solids similar? And if they are similar, I'm going to ask you to give me the scale factor. Remember, when you give the scale factor, you must go from one figure to the other. So for example, on these are bad examples. Let me see, is part B? All right, let's look at B. So for example, if I ask you to first determine if these are similar, what you're going to do is make sure all of the side lengths match up, that the ratios are the same. So you would match 6 and 10, 5 and 3, and 5 and 3 here. So if it asks you from, say, solid A to solid B, if that's the direction they're asking you to go from, you would do 10 over 6, simplify that. Then you would do the blue ones, and I guess I should have done this in color. But then 5 over 3 for the 2 blue ones, and then the 2 red ones. And match them. They must all simplify to the same ratio. And then the order that it's given, if it asks you to give the scale factor from A to B, then in this case, you're going from 10 to 6 or 5 to 3, you would do it this way. You could also leave it the fraction, okay? But you're gonna see it as a ratio with a colon, okay? You can't go and match it within the figure itself. So you have to go from one solid to the other when you set up the ratio. You're also going to know this similar solids theorem. Remember that the ratio of the corresponding sides is A to B. The ratio of the corresponding surface areas is A squared to B squared. And the ratio of the corresponding volumes is A cubed to B cubed. Be able to work with these ratios. I'm going to ask you to find a missing volume given the scale factor, okay, given the volume of the other figure. So be able to answer questions based on the scale factors. So all of these are excellent examples on this page and on the second page. So be able to use your scale factor and your ratios to answer questions. So that's 11-9. Then for the surface area questions, now don't go by what's the lesson up here. This is from a different textbook, but this was a good study guide that we could give you because we had to supplement it. So these are all examples for finding surface areas for cylinders and prisms. The questions on the test are going to look just like the homework. Some of the questions on the test are only going to be asking for the lateral area. And then some of the other ones will ask for the total surface area. So you could go back, rework the test, the homework questions. That would be a good way to study. So this is some examples on the first page. Then they've got some exercises that you can complete to find the surface area of those solids. Then on the next page is the answers for those exercises. And again, disregard the 11-2 at the top. And then here, this is the surface area for pyramids and cones. Again, it's an explanation. And then they have some exercises that you can complete and the answers. So what you should be doing this weekend is going through all of these study guides, going through the homeworks. Again, the questions on the test are going to be straightforward. They're going to ask you to calculate the volume or the surface area or the lateral area. It also may ask you to work backwards and find a height or a diameter or a radius given one of those volumes or surface areas already calculated. You will also have to know about the beginning part, naming it, faces, edges, vertices. So go back through, review. Again, on Monday, any questions that you encounter that you're having trouble with, I will work them out. And then Tuesday, the same thing. And then Wednesday, come prepared. Bring a sharpened pencil with a good eraser, because my pencils, the erasers are gone. And bring a calculator that you know how to use. You can answer all of the questions without a calculator. It's just going to take you a little bit longer. So come prepared. We are not sharing calculators. Any questions?